All right, we're going to take a look at questions 1 and 13 on homework light number 5. Question 1 is about the transitions between levels of a hydrogen atom and the wavelength that gets produced. And the example I was looking at, it went from a starting point of level 4, n equals 4, and we're supposed to calculate the wavelength for the 4 to 3 transition. It also asked at the starting point about the number of lines that you can get from that starting point. And so if you start with an n equals 4, an electron that's elevated up to n equals 4, it could go 4 to 3, 4 to 2, 4 to 1. But then once it's in 3, it could go 3 to 2, or 3 to 1, and once it's in 2, it could go 2 to 1. So you get a total of 6 possible lines from that original starting point. To get any one of the wavelengths of those lines, you plug into the Rydberg formula, which is what we have here. This is the Rydberg constant. So plug in those numbers and you'll get an answer here for 1 over the wavelength. And then you invert this to get the wavelength. So 1 over the wavelength is this number. 1 over this number will give you the wavelength. So that's how you do question 1. For question 13, we're looking at the quantum numbers and ask different properties and what quantum numbers affect them. So for the first one, there's more than one answer because 2 of the quantum numbers are needed to determine the energy. There's the n, which sort of determines the overall energy level, but then there's also L, the angular momentum quantum number. If you're thinking of it like in a mechanical situation, which is not exactly like the mechanics we've thought about before, you can think of it as like it has kinetic energy in its translation, its linear motion, and also kinetic energy tied up with its rotation. So its angular momentum means it has rotational kinetic energy. You can think of it that way. And so both of these quantum numbers will affect the energy. So this is like its 1/2 mv squared, and this is its 1/2 I omega squared. And these don't change the overall energy level. What information is most important in determining the size? So the size is going to be determined by just n alone. That's like how big, like what the energy level. There's a formula connecting n to the radius of the orbit. And so n is the only quantum number that affects the size, the overall size. The orientation is what's given by m sub L. So, and recapping here so far, n is kind of telling you the overall size and basic kinetic energy, linear kinetic energy. L is going to tell you how much rotational kinetic energy it has, essentially, or how much angular momentum it has, and it also describes the shape. But the orientation of it, there's multiple ways to orient that shape of orbital, and that's determined by m sub L. And then I just answered this one, that the general shape is determined by L. Okay, and those are what each of the quantum numbers represent. We didn't really get to m sub s, the spin quantum number. That's a plus or a minus. That's sort of like an up or down. You think of it as the electron has like an up state and down state. So it's not affecting the energy. It's not affecting the size or the shape or how the orbital is oriented, but it's just another property an electron can have, an up or down. And we call it spin, but it's not really, that's just a name for it.